What if the sky fell and hardly anyone batted an eye? Picture this. A cosmic intruder, a silent messenger of potential doom, slips right through our planetary defenses. Its arrival? Completely missed, until long after the echoes of its impact have faded. This isn't some movie plot. This is a real possibility in our huge, chaotic solar system. We're about to explore a what-if scenario, an asteroid strike that went completely unnoticed. A cosmic ghost whose true terrifying size and devastating potential are only now coming to light. This is the chilling story of what could actually happen, and what it means for every single one of us here on Earth. You know, our planet is constantly getting pelted by stuff from space. Most of it is just harmless dust, burning up as those pretty shooting stars we sometimes see. But out there in the cold, dark void float rocks that are a much bigger deal. Asteroids. These things are leftovers from when our solar system was born, like cosmic time capsules. But they're also potential bringers of unimaginable destruction. For decades, dedicated scientists all over the world have been scanning the skies. Think of NASA's Planetary Defense Coordination Office, or survey projects like the Catalina Sky Survey, Pan-STARRS, and Atlas. They're out there, night after night, taking pictures of the sky, looking for faint little specks of light moving against the backdrop of stars. Clever algorithms then crunch this data to predict where these objects are going, figure out if they're dangerous, and hopefully give us a heads up if something nasty is heading our way. We've found thousands of these near-Earth objects, or NEOs, cataloged their paths, and for the most part, we tend to sleep soundly, thinking the big ones are all accounted for. But here's the thing, the solar system is absolutely enormous, and even with our most powerful telescopes, we can't see everything. There are blind spots. Take asteroids approaching from the direction of the sun, for example. They're incredibly tricky to spot. The sun's glare just washes them out. It's like trying to see a tiny fly buzzing right in front of a giant searchlight. And then there's just the sheer number of them. We've found a good chunk of the really massive, kilometer-plus sized asteroids, the kind that could cause a global catastrophe, like the one that did in the dinosaurs. But there are so many smaller yet still incredibly dangerous objects out there. We're talking about asteroids in the range of tens to hundreds of meters. An asteroid just 100 meters across, if it hit us, could unleash energy like hundreds of nuclear bombs. It could wipe a city off the map or cause devastating tsunamis. And here's the really unsettling part. Scientists reckon we've only found a fraction of these city killers. Thousands could still be lurking out there. Their orbit's a complete mystery. Some asteroids are also super dark, meaning they reflect very little sunlight, making them faint and hard to see until they're scarily close. And sometimes, even when we get the data, there's so much of it that objects can be missed, or their importance isn't realized right away. Warnings can come late, sometimes just days or hours before a close call, or even after an object has already zoomed past. Remember the Chelyabinsk meteor back in 2013? It was roughly 20 meters wide and exploded over Russia with the force of about 500 kilotons of TNT. Over 1,000 people were injured, mostly by flying glass. It was a sharp reminder that even relatively small objects can cause serious harm, and that one arrived completely out of the blue. Now, imagine something bigger than Chelyabinsk, maybe 70, 80, or even 100 meters across. Big enough not just to shatter windows, but to flatten buildings, start massive fires, or trigger terrifying tsunamis if it hit the ocean. What if an object like that, due to a bad trajectory, a gap in our sky coverage, or just plain bad luck, managed to reach Earth totally undetected? What if it hit a really remote, unpopulated part of our planet, say, deep in a vast desert, a desolate mountain range, or the huge, unmonitored Pacific Ocean? The initial event, the searing flash and the deafening roar, might go completely unwitnessed by human eyes. The sky would burn, the Earth would shake, but the world at large would carry on, blissfully unaware, at least for a little while. This is the exact scenario we're diving into. A silent impact, a cosmic crime scene with no immediate witnesses. But that silence, it wouldn't last forever. The Earth itself would bear the scars, and slowly, painstakingly, the evidence would start to creep out. So, in our hypothetical situation, the impact has happened. A massive release of energy, like many megatons of TNT, has torn a new wound in some remote part of our planet, or unleashed hell on an empty stretch of ocean. Days, maybe weeks go by. The world just keeps spinning, totally oblivious. But the Earth remembers. The first clues might be tiny, almost unnoticeable, picked up by instruments built for completely different jobs. Global networks of seismometers, those vigilant guards against earthquakes, would register a strange tremor. Not the usual signature of shifting tectonic plates, but something sharper, more sudden. A single violent spike, coming from an area with no known fault lines. Scientists monitoring these networks, perhaps thousands of miles away, would flag it as odd, a puzzle needing a closer look. Then another set of ears would perk up, infrasound detectors. These arrays are designed to listen to ultra-low frequency sounds that humans can't hear. They're part of the Comprehensive Nuclear Test Ban Treaty Organization's global monitoring system and can pick up large explosions anywhere on Earth, whether natural or man-made. An asteroid exploding in the atmosphere or hitting the surface would create powerful infrasound waves, rippling through the air for thousands of kilometers. Analysts looking at this data would find a strong, localized acoustic event matching the time and rough location of that seismic blip. The pieces would start to fit together. If the impact happened in the ocean, hydroacoustic sensors, basically underwater microphones, also part of that same global network, might have recorded the underwater blast and the huge waves that followed. Satellite altimetry data, which measures sea surface height, could even retrospectively show unusual wave patterns spreading out from a specific point, long after the waves themselves had calmed down. Slowly, a picture of a big, energetic event in a remote spot would start to emerge. But what kind of event? A secret weapons test? An unusually violent volcanic eruption? Or something else entirely? The investigation would ramp up. High-resolution satellites would be tasked to zoom in on the suspected location. If it was a land impact, the images might show a brand new crater, maybe kilometers across, depending on how big and tough the asteroid was. They might reveal a huge area of flattened or scorched land, a bit like the Tunguska event in 1908, where an airburst flattened over 2,000 square kilometers of Siberian forest. The Tunguska object, thought to be around 40 to 80 meters in size, exploded in the air, so it didn't leave a classic impact crater, making its cause a mystery for decades. Our hypothetical impactor, if it was a bit bigger or made of denser stuff, might have actually made it to the ground. If the impact was in the deep ocean, you wouldn't see a crater on the surface. But satellites might pick up lingering hotspots in the water, or unusual clouds of atmospheric aerosols, fine dust and particles, kicked up by the giant splash and steam explosion. Specialized atmospheric chemistry satellites could detect strange trace gases or tiny particles shot high into the atmosphere, perhaps even noticing effects on global weather patterns if the impact was big enough to throw a lot of debris skyward. That 1908 Tunguska event, for instance, caused unusually bright night skies over Siberia and Europe for a while because of all the dust scattered in the atmosphere. Scientific teams driven by this mounting multi-pronged evidence would be sent to the suspected impact zone, if it's even reachable. For a land impact, they'd be hunting for telltale signs. Unique shock-metamorphosed rocks, bits of meteorites, high levels of elements like iridium, which are rare on Earth but common in asteroids. Finding that kind of evidence would be the smoking gun. For an ocean impact, research ships might collect deep-sea core samples, looking for freshly laid down layers of impact ejecta or strange chemical signatures in the water. Just imagine it, geologists, geophysicists, and planetary scientists all converging on this remote spot or poring over data from afar. They'd be like cosmic detectives, painstakingly piecing together what happened. How big was it? What was it made of? What angle did it hit at? And the million-dollar question, how did we miss something this huge? The true size would start to become clear, not just from any crater, but from analyzing everything together. The seismic energy, the infrasound signature, the extent of the devastation if on land, or the modeled energy of the ocean impact. Let's say our hypothetical asteroid was 150 meters across, a definite city killer size. An object like this hitting Earth would release energy equal to many hundreds of megatons of TNT. That's way bigger than any single nuclear weapon ever detonated. The initial unnoticed event wasn't some minor hiccup. It was a cataclysm. The shock waves wouldn't just be local. They would have measurably vibrated around the entire planet. The sheer scale would be staggering, the implications terrifying. The world had been smacked by a cosmic cannonball, and for a while, it didn't even realize it. As the evidence mounts and scientists piece together what happened, the colossal size of our unnoticed asteroid impact becomes horrifyingly clear. Let's give our imaginary intruder a diameter 150 meters. Now, this isn't a planet killer like the Chicxulub impactor that spelled doom for the dinosaurs. That one was estimated to be nearly 10 kilometers across and released energy like billions of atomic bombs. But a 150-meter object? That's still a truly massive threat, squarely in the city killer category, capable of causing regional, if not continental, devastation, depending on where it hits. If our 150-meter asteroid, zipping along at typical impact speeds of around 17 kilometers per second, that's over 60,000 kilometers per hour, were to slam into solid ground, the consequences would be almost biblical. Upon impact, it would blast out a crater potentially 2 to 3 kilometers wide and hundreds of meters deep. The energy released would be somewhere in the realm of several hundred to maybe over 1,000 megatons of TNT. To put that in perspective, the bomb dropped on Hiroshima was about 15 kilotons. This is tens of thousands of times more powerful. Within a radius of tens of kilometers from ground zero, absolutely everything would be obliterated. The shockwave alone would flatten even reinforced concrete buildings. An intense heat pulse would ignite fires over a huge area. Further out, for hundreds of kilometers, the effects would still be catastrophic. Buildings would collapse and hurricane-force winds would hurl deadly debris everywhere. Earthquakes, potentially hitting magnitude 6 or 7 on the Richter scale, would be triggered, causing even more destruction. Millions of tons of rock and dust would be blasted into the atmosphere. If this impact happened near a populated area, the death toll would be in the millions instantly. And for anyone who survived, the aftermath would be a living nightmare. The sun blotted out by dust, infrastructure utterly destroyed, a landscape twisted into something alien and hostile. If the impactor was larger, say 300 to 500 meters, the dust and aerosols thrown into the stratosphere could be enough to cause an impact winter, leading to global cooling, widespread crop failures, and famine affecting regions far, far beyond the immediate blast zone. Now let's think about an oceanic impact. This is actually more likely since over 70% of Earth's surface is water. Our 150-meter asteroid plunging into the ocean would create a colossal splash and a massive cavity in the water. The immediate underwater explosion would be devastating to marine life for hundreds of kilometers. But the much bigger threat would be tsunamis. Not just one wave, but a series of enormous waves radiating out from the impact point. If the impact happened in the deep ocean, far from land, these waves might lose some of their punch before reaching coastlines. However, an impact on a continental shelf or closer to shore could generate tsunamis tens, even hundreds of meters high. These monstrous waves would inundate coastal cities and low-lying regions across entire ocean basins. The warning time for these kinds of impact-generated tsunamis would be practically nothing, far less than for earthquake-generated tsunamis, where seismic waves travel much faster than the water waves. Millions could die in minutes. The 2004 Indian Ocean tsunami, triggered by an earthquake, showed us just how devastating and far-reaching such waves can be. An asteroid impact could be far, far worse. The truly terrifying thing about this unnoticed event isn't just the raw, destructive power, but the chilling realization of its stealth. It slipped right through our defenses. This wasn't some distant threat we had decades to prepare for. It was a clear and present danger that arrived completely unannounced. It throws a harsh spotlight on the gaps in our current detection capabilities, especially for objects coming from the direction of the sun, those with very dark surfaces, or those whose orbits are chaotic and hard to predict. It really hammers home the fact that while we're getting better at finding these cosmic menaces, the sky is still full of unknowns. Current estimates suggest there are potentially 14,000 undiscovered city-killer-sized asteroids, 140 meters and larger, in Earth's neighborhood. The psychological shock of such a discovery would also be immense. The illusion of safety shattered. The realization that, despite all our technology, we're still vulnerable to the whims of the cosmos. It would force a global rethink of planetary defense priorities. The question would no longer be if something like this could happen, but when the next one might occur, and how on earth could we stop it if we can't even see it coming? This hypothetical, unnoticed impact is a chilling testament to the persistent and often underestimated danger lurking in the darkness between worlds. The news of a previously unnoticed major asteroid impact, even a hypothetical one over a remote area, would send shockwaves much bigger than any seismic tremor. It would be a brutal, undeniable wake-up call for all of humanity, forcing us to face the gaps in our planetary defense and the very real, ongoing threat from above. So, what lessons would we learn from such a terrifying discovery? First off, it would hammer home the desperate need to upgrade our detection capabilities. Sure, current surveys have made amazing progress, finding most of the kilometer-scale giants that pose a global existential threat. But this unnoticed impact would prove that objects big enough to cause regional devastation can still slip through our net. We'd need more eyes on the sky, working around the clock, covering all angles, including those tricky sunward approaches. This means investing in a wider network of ground-based telescopes, like the upcoming Vera C. Rubin Observatory in Chile, which will scan the sky with incredible depth and speed. But crucially, it also means more space-based observatories. Missions like NASA's NEO Surveyor, a dedicated infrared space telescope planned for launch in the late 2020s, are designed specifically to find these sneaky asteroids, including those that ground-based telescopes might miss. Such a near miss, or in our scenario, a post-impact discovery, would light a fire under efforts to accelerate and expand these programs, and probably kickstart new ones too. Secondly, the event would highlight just how important rapid characterization and response are. Once an object is detected, especially if it's on a collision course with very little warning, we need to be able to quickly figure out its size, what it's made of, and its exact trajectory. This info is vital for predicting impact effects and, if we have a chance, mounting a deflection mission. The DART, Double Asteroid Redirection Test mission, which successfully nudged the asteroid Dimorphos off course in 2022, was a fantastic proof of concept for kinetic impactor technology. But DART had a known target and years of planning. An unnoticed impact scenario shows we need rapid response capabilities, the ability to launch a scout mission or even a deflection mission at very short notice. Thirdly, international cooperation would become even more vital. Asteroid impacts are a global problem. They don't care about national borders. A coordinated global effort for detection, sharing data, and planning a response is absolutely essential. Organizations like the International Asteroid Warning Network, IAWN, and the Space Mission Planning Advisory Group, SMPH, already exist to help with this, but their authority and resources would likely get a major boost. Beyond the tech and political fixes, an event like this would fundamentally change how we see our place in the universe. That abstract threat of an asteroid impact would become shockingly real. It would foster a greater appreciation for how fragile our planet is and how important scientific research is for protecting our future. It might even spark a new era of space exploration, driven not just by curiosity, but by the very practical need to understand and deal with threats from beyond Earth. The story of our unnoticed impact isn't just about the terrifying power of nature. It's about our own vulnerabilities and our ability to learn and adapt. It would be a stark reminder that the cosmos isn't always friendly, and that staying alert is the price of our continued existence on this little blue marble. The echoes of this silent impact would ironically be deafening, pushing us to renew our commitment to protecting our world. We have the smarts and increasingly the technology to become true guardians of our planet. This shocking discovery would be the ultimate push to fully step into that role. The sky fell, we didn't see it coming, but we absolutely must make sure we're looking up, much more carefully for the next time. The tale of an unnoticed asteroid impact, a colossal event hidden in plain sight, really brings it home. Our planet is just a tiny traveler in a cosmic shooting gallery, while our story today was a what-if. The dangers lurking out there are very, very real. We've explored how such an event could sneak past our current watch, the incredible scale of destruction it could cause, and that terrifying moment of realizing just how vulnerable we are. But it also shines a light on our own ingenuity and our growing power to face this challenge. The darkness of space holds dangers, sure, but it also fuels our drive to understand, to innovate, and ultimately, to protect ourselves. What are your thoughts on the risks from asteroids? Does the idea that a major impact could go unnoticed, at least at first, worry you? Do you think we're doing enough to find these hidden threats? Let me know what you think in the comments below. And if you found this journey into the cosmic unknown interesting, please hit that like button, subscribe for more deep dives into science and space, and make sure to check out our next video. We'll be looking at the cutting-edge technologies scientists are developing to defend Earth from the next big space challenge. Stay curious and keep looking up.